A syllogism is a kind of logical argument that applies deductive reasoning to arrive at a conclusion based on two or more propositions that are asserted or assumed to be true. In its earliest form, defined by Aristotle, from the combination of a general statement and a specific statement, a conclusion is deduced. For example, knowing that all men are mortal and that Socrates is a man, we may validly conclude that Socrates is mortal. Syllogistic arguments are usually represented in a three-line form. All men are mortal, Socrates is a man, therefore, Socrates is mortal. Early history. In antiquity, two rival theories of the syllogism existed: Aristotelian syllogistic and Stoic syllogistic. Aristotle defines the syllogism as a discourse in which certain things having been supposed, something different from the things supposed results of necessity because these things are so. Despite this very general definition, in Aristotle's work Prior Analytics, he limits himself to categorical syllogisms that consist of three categorical propositions. These include categorical modal syllogisms. From the Middle Ages onwards, categorical syllogism and syllogism were usually used interchangeably. This article is concerned only with this traditional use. The syllogism was at the core of traditional deductive reasoning, where facts are determined by combining existing statements, in contrast to inductive reasoning where facts are determined by repeated observations. Within academic contexts, the syllogism was superseded by first-order predicate logic following the work of Gottlob Frege, in particular his Begriffsschrift, but syllogisms remain useful in some circumstances, and for general audience introductions to logic. Aristotle. The use of syllogisms as a tool for understanding can be dated back to the logical reasoning discussions of Aristotle. Prior to the mid-12th century, medieval logicians were only familiar with a portion of Aristotle's works, including titles such as Categories and On Interpretation, works that contributed heavily to the prevailing Old Logic, or Logica Vetus. The onset of a new logic, or Logica Nova, arose alongside the reappearance of Prior Analytics, the work in which Aristotle develops his theory of the syllogism. Prior Analytics, upon rediscovery, was instantly regarded by logicians as a closed and complete body of doctrine, leaving very little for thinkers of the day to debate and reorganize. Aristotle's theories on the syllogism for assertoric sentences was considered especially remarkable, with only small systematic changes occurring to the concept over time. This theory of the syllogism would not enter the context of the more comprehensive logic of consequence until logic began to be reworked in general, in the mid-14th century by the likes of John Buridan. Aristotle's Prior Analytics did not, however, incorporate such a comprehensive theory on the modal syllogism, a syllogism that has at least one modalized premise. Aristotle's terminology in this aspect of his theory was deemed vague and in many cases unclear, even contradicting some of his statements from On Interpretation. His original assertions on this specific component of the theory were left up to a considerable amount of conversation, resulting in a wide array of solutions put forth by commentators of the day. The system for modal syllogisms laid forth by Aristotle would ultimately be deemed unfit for practical use, and would be replaced by new distinctions and new theories altogether. Medieval Boethius contributed an effort to make the ancient Aristotelian logic more accessible, while his Latin translation of Prior Analytics went primarily unused before the 12th century. His textbooks on the categorical syllogism were central to expanding the syllogistic discussion. Boethius' logical legacy lay not in any addition he personally made to the field, but rather in his effective transmission of prior theories to later logicians, as well as his clear and primarily accurate presentations of Aristotle's contributions. Peter Abelard, another of medieval logic's first contributors from the Latin West. Peter Abelard gave his own thorough evaluation of the syllogism concept and accompanying theory in the Dialectica, a discussion of logic based on Boethius are commentaries and monographs. His perspective on syllogisms can be found in other works as well, such as Logica Ingredientibus. With the help of Abelard's distinction between didictomodal sentences and iremodal sentences, medieval logicians began to shape a more coherent concept of Aristotle's modal syllogism model. John Buridan, whom some consider the foremost logician of the later Middle Ages, contributed two significant works: Treatise on Consequence and Summuli de Dialectica, in which he discussed the concept of the syllogism, its components and distinctions, and ways to use the tool to expand its logical capability. For 200 years after Buridan's discussions, little was said about syllogistic logic. Historians of logic have assessed that the primary changes in the post-Middle Age era were changes in respect to the public's awareness of original sources, a lessening of appreciation for the logic's sophistication and complexity, and an increase in logical ignorance, an ignorance heavily ridiculed by logicians of the early 20th century. Basic structure. A categorical syllogism consists of three parts: major premise, minor premise, conclusion. Each part is a categorical proposition, and each categorical proposition contains two categorical terms. In Aristotle, each of the premises is in the form all A are B, some A are B, no A are B, or some A are not B, where A is one term in B is another. All A are B, and no A are B, are termed universal propositions. Some A are B, and some A are not B, are termed particular propositions. More modern logicians allow some variation. Each of the premises has one term in common with the conclusion. In a major premise, this is the major term. In a minor premise, it is the minor term of the conclusion. For example, major premise: all humans immortal. Minor premise: all Greeks are humans. Conclusion: all Greeks immortal. Each of the three distinct terms represents a category. In the above example, humans, mortal, and Greeks. Mortal is the major term, Greeks the minor term. The premises also have one term in common with each other, which is known as the middle term. In this example, humans. Both of the premises are universal, as is the conclusion. Major premise: all mortals die. Minor premise: all men are mortals. Conclusion: all men die. Here, the major term is die, the minor term is men, and the middle term is mortals. Again, both premises are universal, hence so is the conclusion. Asserted is a form of argument in which a series of incomplete syllogisms is so arranged that the predicate of each premise forms the subject of the next until the subject of the first is joined with the predicate of the last in the conclusion. For example, one might argue that all lions are big cats, all big cats are predators, and all predators are carnivores. To conclude that therefore all lions are carnivores is to construct a Asserted argument. Types. There are infinitely many possible syllogisms, but only 256 logically distinct types and only 24 valid types. A syllogism takes the form: major premise: all M are P. Minor premise: all S are M. Conclusion: all S are P. The premises and conclusion of a syllogism can be any of four types, which are labeled by letters as follows. The meaning of the letters is given by the table. In analytics, Aristotle mostly uses the letters A, B and C as term placeholders, rather than giving concrete examples, an innovation at the time. It is traditional to use is rather than are as the copula, hence all A as B rather than all as are B's. It is traditional and convenient practice to use A, E, I, O as infix operators so the categorical statements can be written succinctly. The letter S is the subject of the conclusion, P is the predicate of the conclusion, and M is the middle term. The major premise links M with P and the minor premise links M with S. However, the middle term can be either the subject or the predicate of each premise where it appears. the differing positions of the major, minor, and middle terms gives rise to another classification of syllogisms known as the figure. Given that in each case the conclusion is SP, the four figures are. Putting it all together, there are 256 possible types of syllogisms. Each premise and the conclusion can be of type A, E, I or O, and the syllogism can be any of the four figures. A syllogism can be described briefly by giving the letters for the premises and conclusion followed by the number for the figure. For example, the syllogism Barbara below is a.a.a. 1, or a.a.a. in the first figure. The vast majority of the 256 possible forms of syllogism are invalid. The table below shows the valid forms. Even some of these are sometimes considered to commit the existential fallacy, meaning they are invalid if they mention an empty category. These controversial patterns are marked in italics. All but four of the patterns in italics are weakened moods, i.e., it is possible to draw a stronger conclusion from the premises. The letters A, E, I, O have been used since the medieval schools to form mnemonic names for the forms as follows. Barbara stands for a.a.a., Celarent for e.a.e., etc. Next to each premise and conclusion is a shorthand description of the sentence. So in a.a.i. 3, the premise, all squares are rectangles, becomes map. The symbols mean that the first term is the middle term. The second term is the predicate of the conclusion, and the relationship between the two terms is labeled A. The following table shows all syllogisms that are essentially different. The similar syllogisms share actually the same premises, just written in a different way. For example, some pets are kittens could also be written as some kittens are pets. In the Venn diagrams, the black areas indicate no elements, and the red areas indicate at least one element. Examples: Barbara, all men are mortal. All Greeks are men. All Greeks immortal. Celarent, similar. Cesare, no reptiles have fur. All snakes are reptiles. No snakes have fur. Dari, similar. Datizzi, all rabbits have fur. Some pets are rabbits. Some pets have fur. Ferio, similar. Festino, Ferrison, Fresison, no homework is fun. Some reading is homework. Some reading is not fun. Barrico, all informative things are useful. Some websites are not useful. Some websites are not informative. Bocado, some cats have no tails. All cats are mammals. Some mammals have no tails. Barbari, all men are mortal. All Greeks are men. Some Greeks immortal. Celarent, similar. Cesaro, no reptiles have fur. All snakes are reptiles. Some snakes have no fur. Camastris, similar. Calmos, all horses have hooves. No humans have hooves. Some humans are not horses. Philapton, similar. Phesipo, no flowers are animals. All flowers are plants. Some plants are not animals. Darapter, all squares are rectangles. All squares are rhombuses. Some rhombuses are rectangles. Table of all syllogisms. This table shows all 24 valid syllogisms, represented by Venn diagrams. Columns indicate similarity, and are grouped by combinations of premises. Borders correspond to conclusions. Those with an existential assumption are dashed. Terms in syllogism. We may, with Aristotle, distinguish singular terms such as Socrates and general terms such as Greeks. Aristotle further distinguished terms that could be the subject of predication, and terms that could be predicated of others by the use of the copula. In Aristotle's view, singular terms were of type and general terms of type. Thus men can be predicated of Socrates, but Socrates cannot be predicated of anything. Therefore, for a term to be interchangeable, to be either in the subject or predicate position of a proposition in a syllogism, the terms must be general terms, or categorical terms as they came to be called. Consequently, the propositions of a syllogism should be categorical propositions, and syllogisms that employ only categorical terms came to be called categorical syllogisms. It is clear that nothing would prevent a singular term occurring in a syllogism, so long as it was always in the subject position. However, such a syllogism, even if valid, is not a categorical syllogism. An example is Socrates is a man, all men are mortal, therefore Socrates is mortal. Intuitively this is as valid as all Greeks are men, all men are mortal, therefore all Greeks are mortals. To argue that its validity can be explained by the theory of syllogism would require that we show that Socrates is a man is the equivalent of a categorical proposition. It can be argued that Socrates is a man is equivalent to all that are identical to Socrates are men. So our non-categorical syllogism can be justified by use of the equivalents above and then citing Barbara. Existential import. If a statement includes a term such that the statement is false if the term has no instances, then the statement is said to have existential import with respect to that term. It is ambiguous whether or not a universal statement of the form all A is B is to be considered as true, false, or even meaningless if there are no A's. If it is considered as false in such cases, then the statement all A is B has existential import with respect to A. The following problems arise. In natural language and normal use, which statements of the forms all A is B, no A is B, some A is B and some A is not B have existential import, and with respect to which terms? In the four forms of categorical statements used in syllogism, which statements of the form AAB, AEB, AIB and AOB have existential import, and with respect to which terms? What existential imports must the forms AAB, AEB, AIB and AOB have for the square of opposition be valid? What existential imports must the forms AAB, AEB, AIB and AOB have to preserve the validity of the traditionally valid forms of syllogisms, and the existential imports required to satisfy above such that the normal uses in natural languages of the forms all A is B, no A is B, some A is B and some A is not B are intuitively and fairly reflected by the categorical statements of forms AAB, AEB, AIB and AOB. For example, if it is accepted that AIB is false if there are no A's and AAB entails AIB, then AIB has existential import with respect to A, and so does AAB. Further, if it is accepted that AIB entails B, then AIB and AAB have existential import with respect to B as well. Similarly, if AOB is false if there are no A's, and AEB entails AOB, and AEB entails B, then both AEB and AOB have existential import with respect to both A and B. It follows immediately that all universal categorical statements have existential import with respect to both terms. If AAB and AEB is a fair representation of the use of statements in normal natural language of all A is B and no A is B respectively, then the following example consequences arise. All flying horses are mythological is false if there are no flying horses. If no men are fire-eating rabbits is true, then there are fire-eating rabbits is true, and so on. If it is ruled that no universal statement has existential import, then the square of opposition fails in several respects and a number of syllogisms are no longer valid. These problems and paradoxes arise in both natural language statements and statements in syllogism form because of ambiguity, in particular ambiguity with respect to all. If Fred claims all his books were Pulitzer Prize winners, is Fred claiming that he wrote any books? If not, then is what he claims true? Suppose Jane says none of her friends are poor. Is that true if she has no friends? The first-order predicate calculus avoids such ambiguity by using formulae that carry no existential import with respect to universal statements. Existential claims must be explicitly stated. Thus, natural language statements, of the forms all A is B, no A is B, some A is B, and some is not B, can be represented in first-order predicate calculus in which any existential import with respect to terms A and or B is either explicit or not made at all. Consequently, the four forms AAB, AEB, AIB, and AOB can be represented in first-order predicate in every combination of existential import, so it can establish which construal, if any, preserves the square of opposition and the validity of the traditionally valid syllogism. Strawson claims such a construal is possible, but the results are such that, in his view, the answer to question above is no. On the other hand, in modern mathematical logic, however, statements containing words all, some, and no, can stated in terms of set theory. If the set of all A's is labeled as S and the set of all B's as S, then all A is B is equivalent to S is a subset of S, or SS. No A is B is equivalent to the intersection of S and S is empty, or some A is B is equivalent to the intersection of S and S is not empty, or some A is not B is equivalent to S is not a subset of S. By definition, the empty set is a subset of all sets. From this it follows that, according to this mathematical convention, if there are no A's, then the statements, all A is B, and no A is B, are always true, whereas the statements, some A is B, and some A is not B, are always false. This, however, implies that AAB does not entail AIB, and some of the syllogisms mentioned above are not valid when there are no A's.